Hello everyone. This week is week 10. So from this week, we're going to use 2 weeks to explain how to use database to process data and information. And database is one of the most important part in the IT area. As we know that nowadays there's a huge amount of data every day, everywhere. So how to efficiently process data, use data to help us to improve the efficiency and productivity is critical. It's critically important. So let's start. This is the outline of today's lecture. So first, I will spend some time to explain some fundamentals about database and data and information. For example, the source storing and validating data and different types of databases. And second, I will demonstrate to you how to use access to deal with data. So about reading, so you are encouraged to read this module in your textbook or other relevant materials from other sources. So first is databases, data, and information. So if we remember in our first week's lecture, we have talked about this data and information. So what's the difference between data and information? So data is a collection of unprocessed items. So anything can give us a lot of data, like the weather, like your cars, your home facilities, your actual daily activities, all will produce a huge amount of data. And this data is not has been processed, so we can call it as data. So what is information? Information is processed data for the meaningful use. So that's the major difference. So for example, there's one food factory in Shepperton. They have a collaboration with us. So previously, they have a huge amount of data produced from their machine every day. So because they had deployed different sensors, different machines to get a lot of data from their production line. But before, they have no idea how to use this data. So even to have a huge amount of resource as a data, they don't know how to do with that. And this data will be just wasted. So after they collaborate with us, so we'll help them to build a module to process data like real time, fast, to extract the information, the useful information from it. We can use this information to predict the machine failure, to reduce the downtime, and also to try to detect those defective items, so make their working more efficiently and more productively. So that's the difference between information and data. Since in order to process data and change it to information, first we need to find a way to store our data. So how to do with that? Then we have to use a database. So database theoretically is a collection of the organized data, but this is definition from your textbook previously. But nowadays, a database can be a collection of organized data or unorganized data as well. So it doesn't need to be organized, because these days, especially due to the big data, so many data will from different sources, and in most cases, this data, especially from the different sensors, different systems, they are unorganized or unstructured, but we still can collect it and store in the database. So first, let's look at how to store and validate data. So in order to efficiently process data, we need to use the correct way to store our data first. So usually the data should be well organized in levels. And here is an example that how we should store our data in the database. And here there are some new terms for you, like characters, fields, and records, and data files. So for example, the character means one letter or one number in one item. Fields means one complete data item in the database. A record, it means several fields combined together to form one complete information. And the data field means the whole data set consists of several records. And here are some more explanation of each term. So for example, one character is about 1 byte. It could be numbers, letters, blank space, punctuation marks, or other symbols. So one field is a combination of one or more related characters. Could be file names, field size, or data type. A record is a group of related fields. So a primary key is a field that uniquely identifies each record. So a primary key is a very important concept you should bear in mind, and we'll use that later. Then is the data file. So data file is a collection of related records. So it consists of several records together to form a whole data file. So that is all about storing our data in the organized way. Then what do we mean by file maintenance? So file maintenance means the procedure that keeps the data current. For example, we add new data or modify the existing data or delete the useless data or useless record. And then how to validate our data. So usually this can be done by comparing data with a set of rules or values to determine if this data meets the certain criteria. So we can do the alphabetic check or numeric check. Means that there are some like the field or records should contain the certain letters or should be only letters or should be only numbers. We can do this check. Also, we can do the range check. So if this field is just number, so does the number fall into the available range? Then it's the constancy check, because some data can be changed, some cannot. So we can do this constancy check. And then it's the completeness check. Especially as a whole record, is every information has been filled or is there any missing information there? Then there's a digit check, because some numbers will require a certain amount of digits. So does it meet the requirements, or there could be many other checks. Then let's look at the databases and the Dbms. So what is the definition of the database? So database is a collection of information that is organized so that it can be easily accessed, managed, and updated. And the database management system, short for DBMS, is a system software for creating and managing databases. So the DBMS provides users and programmers with a systematic way to create, retrieve, update, and managing data. So here you should remember that DBMS, database management system, is a system software, not application software. So it may be different from what you thought. So that's what you should bear in mind. And then it is DBMS functionalities, which includes first data storage, retrieval, and updates. And this is the core functionality for DBMS, of course. So the reason we use the DBMS is to store the data, deal with data, and update our data. And second functionality is a support for transactions and concurrency. So databases should not be only used for data storage, because in reality, we may have many different databases, and how to exchange information and data between different databases is also very important functionality. Just like different banks, so different bank has different databases, and how the user can transfer money from one bank to another bank. So it's similar like the data transaction between different databases. And also the concurrency is also important. So database concurrency basically refers to the ability of the database to support multiple users and processes at the same time. So concurrency improves system performance and the throughput, but not without its side effects. Then is the facilities for recovering the database should it become damaged. So since many databases they store very sensitive, valuable data, and this data usually stored in the hard drive. Due to some reason, the data in the hard drive may be damaged or lost. So how can we recover this damaged or corrupted data? Is another very important functions for the database. Then support for authorization of access and update of data. So data is kind of like property. In most cases, this data belongs to a group or organization or some parties. So only the authorized person or groups have access to the corresponding data. So how to deal with this access control to the databases is important, and only the validated users can update the data. So invalid users should not have access to this data or even not update this. So this is also important. Then is the access support for remote locations. So as we know that these days, data center and the cloud center, they are usually located in some very rural area due to the low cost. So how to get access to those remote data center is also important. So finally, is to enforce constraints to ensure data in the databases abides by certain rules. So we should set up many rules in our database to make sure that data in the databases follow these rules. So that's also another fundamental functions in the database. So some of you may have questions so spreadsheet is also very useful tools to store and deal with data, and it's very easy to use. Then why we still need to use a database? And here I give this table to summarize the difference between a spreadsheet and a database. So you can see why we should still use the database in most cases. So in this table, I compare spreadsheet and Dbms from different angles. First is the data organization. So in spreadsheet, it is store the data value in cells. Since you have used spreadsheet before, so you know that. But in the Dbms, in the database, it store the data value in tables. So that's one major difference. So the second is the volume of the data. So in the databases, in the spreadsheet, it is not very good for long-term storage of the raw data. If you notice that in the Microsoft Excel, there exists maximum rows or columns in one spreadsheet file. So if your size of data is larger than that, you cannot save everything in one file. You have to split and save in another spreadsheet. So which is inconvenience if you have a large data set. But for like a Dbms, there's no problem. It can deal with a large amount of data of the raw data. Then is the data processing. So for the data processing of the spreadsheet, I would say it's like for the simple processing, it's very simple. For example, you want to search for something, you want to replace it, you want to delete it, you want to filter it. It's just very simple. Just click your mouse and type something. Use the keyboard. Then you can easily change, delete, or find the value you want. But for the Dbms, it's much more complicated. So usually for the database, you want to add new data, update new data, or update some data. You have to use the programming language called SQL to deal with that. And also sometimes due to the protection of the databases, sometimes you have to get access to the database first, then you can start the process. And so after that, you also need to back up your data just in case one day you want to recover your data. So it's much more complicated in the Dbms. Then it's the number of users. So for the spreadsheet, it's one user at a time. So even you share with your spreadsheet to many users, so it means that many people can have access to this one spreadsheet, but only one people allowed to change the data in the spreadsheet at a time. But it's different for the database. So different people, more like many users can change the information or data in the database at the same time. So it means that it will easier for people to co-work together to deal with data. So by using database, I would say it's more suitable for the big project when you have a lot of data. Finally, is the data virtualization. Of course, for the spreadsheet, it was very simple because you can directly see your data from in a cell, and also you can, as we learned, that we can use a different data virtualization method in the spreadsheet to draw the different graph, the line or the pie and bar. So it will be very easy for the data virtualization in the spreadsheet. But for the Dbms database, it require a higher level of the technological expertise. So that's why that's the major difference between the spreadsheet and the databases. So but from here you can see that for small like a project, a simple information, a small data set, you can just use a spreadsheet. It's much more convenient. That's why in many like the accounting firm, they prefer to use a spreadsheet because their data is very the data set is small and they need to frequently change data and it's easier to demonstrate the data to their clients. So in many commercial like accounting companies, they prefer to use data sheet. Oh no, sorry, the spreadsheet. But for the like IT companies, especially like Google, Facebook, have huge amount of data. So then they prefer to use a database management system to deal with data. So that's the major difference. And now please spend some time to think about any examples of DBMS applications in our daily lives. So if you finish this, you can continue with the lecture. So now let's look at different types of DBMS. So depending on the different angles, different aspects, we can define the types of DBMS in different ways. And here is just one most popular ways to define this DBMS type. And here I just give 4 different types. So first is the relational databases called for RDB. Then is the object-oriented databases, short for OODB. Then is the network databases. And finally is the non-relational databases, short for NoSQL. So let's look at this one by one.
So first is relational databases. So a relational database organizes the data into tables, which can be linked or related based on data common to each other. This capability enables you to retrieve an entirely new table from data in one or more tables, which with one single query. So it also allows you and your business to better understand the relationship among all available data and gain new insights for making better decisions or identifying new opportunities. And second is object-oriented databases, so it's short for OODB. So as the name implies, the main feature of this object-oriented databases is allowing the definition of objects, which are different from normal database objects. So objects in an object-oriented database reference the ability to develop a product and then define and name it. So the object can then be referenced or correlated as a unit without having to go into its complexities. So it is very similar to the objects used in the object-oriented programming. And then it's the network database. So in a network database, multiple member records and files can be linked to multiple owner files or vice versa. So the key advantage of a network database module is supports many-to-many relationship and then provides greater flexibility and accessibility. So the result is faster data access, search, and navigation. So finally is the non-relational databases, so for NoSQL. So a NoSQL database is exactly the type of the database that can handle the source of unstructured and messy and unpredictable data that our system of engagement requires. So in reality, most data are unstructured, unorganized, and in order so to process this kind of data, to use original data is very difficult. So that's why nowadays, especially to deal with the big data, we have to use this non-SQL to do the data processing. Okay, now let's move to the second part of today's lecture, database management system. As I emphasized many times, so database is one of the key technologies in IT area. So at the core of an management information system is a database or many databases. And the data files are usually stored in our hard drive. And here is an example of a database. You can see that all data is stored in an organized way. So for example, it has a different fields and field names, and the record consists of different fields, and the whole is called a data set. Then the characteristics of an instructor ID field, it has many properties like the field size, which means the maximum characters in instructor ID field, and what's the format, so what's the caption default value, as many properties. So as I mentioned before, Dbms software is one kind of a system software. It helps in keeping the data guarded and safe, reducing data redundancy, and maintaining the efficiency and the throughput of data. And in reality, there exists a great number of Dbms software. And here I just listed some most popular Dbms software. So first is Oracle Dbms. So Oracle database is one of the most widely used object relational database management software. So many big companies, they intend to use Oracle database as their solution. IBM DB2 used to be very popular. It was developed in last century, 1983, and recently less people use this system. And the Microsoft SQL Server, it is also another very popular relational DBMS developed by the Microsoft because of the big impact from Microsoft. So many companies use the SQL Server as well. And next is MySQL or MySQL. So this is used to be open source, but now it is owned by Oracle. It's supposed to be very easy to use, free to download, and compatible on many operating systems. So not only Microsoft Windows, but also the Mac OS or the Linux as well. Then is the SQLite. So SQLite is one of the most popular choice for the embedded database software, because in many embedded systems, memory and storage size is very limited and constrained. So those traditional database software will be very hard to use in these small devices. Then SQLite is one of the best solution in this scenario. And then is the PostgreSQL. So this software is the most advanced open source DBMS software developed by a worldwide team of volunteers. So if you want to use the open source DBMS, I will highly recommend these tools. It's totally free, totally open source, and it has many good functionalities. And this year's MongoDB becomes more and more popular because this database can process a huge amount of data simultaneously. And another important thing about MongoDB is also open source, and it can deal with the unstructured data. So many previous ones can only process the organized or structured the data set, but MongoDB can deal with the unstructured, so which is perfect for the big data. So that's why MongoDB become more and more popular these years. And last is the Microsoft Access. So Microsoft Access is, I would say, is always popular because it's quick and easy to use, and it's very user friendly. So for many beginners of the database, you can start with the Microsoft Access. And also, if you have the Microsoft Office suite, it contains the Access, this software. So that's why it is very popular in some small business and startup companies. And in our lecture, we'll focus on this Microsoft Access as our learning tool. Let's look at how to do the relational database design. So what is the correct design for a database? So we can start with an example. And here is the example. And we try to design a single table to store all this information. And you can try by yourself. You can pause your video here and try it by yourself. And this is the table to store all the information previously. So we can translate all this into one table. It's like this. So then my question is, if Liam want to change his address, and how many changes is needed to be made to this table? Please think about it. So obviously the answer is 4. So you have to change these 4 places of Liam's address. So you may ask, can we use the self-reference? So first is the main one, the other is just reference to the first one. Yes, then you can only change once. But one problem is that you have to remember, okay, this is the main one, and the other is the reference one. So it's also will have some difficulties for the maintenance, because you have to distinguish between the main cells and other is the reference cells. But by using database, we don't have this issue. So from the previous example, what I want to emphasize is that putting all your data in a single table means you have end up with data redundancy. And the data redundancy is considered to be the scourge of all database design. And why data redundancy is so not welcomed? Because data redundancy will not only cause the data inquiry problem, because you may have different copies, but also it will dramatically increase the size of the database. So we should avoid this data redundancy in your database design. Then how can we avoid this data redundancy in our database design? And the answer is to use relational database software. So the database, relational database will get rid of all the data redundancy depending on the data relationship. So any piece of data is only stored once in this relational database software. So that is the most important thing you need to bear in mind. Okay, now let's learn how to use Access to create tables. So first, if we want to apply a relational database design to the previous order form in the previous example, first we need to divide the tables into these 4 related tables. So these 4 subtables or related tables is based on this previous whole table. So because this table is huge, so we want to more efficiently design our database. We can divide it based on the relationship. Here, based on the relationship here, we divided the whole table into these 4 small tables. They will ask, can we divide into 5 or 3 or more tables? Okay, that's a total depends on your database design. So you can try more tables if you want, but here in this example, we only have these 4 related tables. Now you can check. So now if Elaine wants to change his address, how many changes need to be made in this case? Of course, we only need to change once. So instead of the table here, we have to change 4 times. So now we have 4 separate but related tables. And then how to maintain the links between these tables. Now we need a field in each table which uniquely identifies each record. And this record we call a primary key. So some software are needed to maintain the links, which now is Microsoft Access. And this primary key is nearly always a number, but actually it doesn't have to be a number. It can be a string or can be a letter, but you know, the letter and the string sometimes depends on the small letter, capital letter, and sometimes it contains a web strange character. So in order to maintain a good database, you are recommend to use a number as your primary key. So now we can use this Microsoft Access as our Dbms tools. Okay, now I will show you how to use the Microsoft Access to create a database from scratch. So where I will demonstrate creating tables, and in the tables there's 2 views. One design view to create the outline of the main content of the table, then the data sheet view. Then we can fill in all the detailed information in this table, and then we need to set this primary key or keys depends on your table, and then I will show how to create relations between these different tables. And finally, it's necessary to set this like a referential integrity to guarantee the correctness of your database. So first, we click the Microsoft Access, and then you look like this. First, you need to double click the blank database. Then a new database file will be created. So table will be automatically created for you, so that's okay. So for the table, if you do the right click here, you can see that there will be 2 views here. One is the design view and one is the datasheet view. So first we need to switch to the design view. So then you need to give a name. So so since we need to create these 4 tables, so we can give each table a name. So we'll use this as a table name. So we'll give a name like customers. Then we need to design the format of this table. So in this table, so let's go back. You will see that it has two formats. It's like two items. One is the custom name, and there's the custom address. So back to the database, we will give first is the custom name, and the data type. Since it's name, we'll give it's a short text. Then it's the custom address. Since address will be quite long, so we'll give a long text. Then we can change back to the datasheet view. First, we need to save it. Datasheet view, we can fill in the details. So we need to fill in like the and address is Sydney. Second is the line name. The address is Greece. So both design view and the datasheet view are now completed. So now let's create another table. So back to the slides. So we have another 3 tables, so we can continue to create some other tables. So we can second, we can create this table. We call the order table. So now let's go back to create another table. So here we just click create another table. And so here, if you want to change the table name, you have to switch to the design view. So give a name like item order. So here we need to define the layout. So if you order number, so it should be number. Second is item number. So the data type is also number. Then is the quantity, it's also number. Then we can save it and switch back to the datasheet view. So now it's back to the datasheet view. We need to fill in all this information from the table. So the order number, item number, quantity, and then second is also the name, and well. So now you can see this error is that the changes required the table were not successful because it created like duplicated value in the index. The primary key means that since by default is the order number is the primary key. Now we have the primary key has 2 the same values, so which is not allowed. So how can we solve this issue? First, we need to delete this. Okay, we need to give it number, any number, and then we need to switch back to the design view. See, now with this order number is only the primary key, so it means that we cannot have the same order number in this table. So in order to save this issue, we need to define the 2 primary key as a pair. So then we can have a different, we can have a same order number, but like with a different item number. So if the pair is different, then we can consider it's a different the record. How can we define two fields as a primary key? We need to select both, and then click here. When you see these keys here, it means that both field will be selected as a primary key. Now let's save it and switch back to the datasheet view. Then we can try again. Okay. Now you can see it will accept this. So it can accept this same order number here. So I will continue to type in all the information. So I will skip this part. So now all this information has been filled in this table. So we'll continue to create another 2 tables. Okay, now these 4 tables are all created. So you can click and switch to different design to check the details. And in each table, you need to check the primary key. So in this table, the primary key is the customer number, and this one is the item number is the primary key. So the item order is so these 2 are the primary keys, and finally the order number in this table is the primary key. So now 4 tables have been created, and the next step is to set up relationship between these 4 tables. So how to do that? First, we need to click here, so database tool, Then we click relationships. Now it's a blank because we haven't set up anything. Then we need to click show table, and then we need to show all the tables. We can click one table and add another, third, and last. We put all four tables here. We need to set the relationship between them. Okay, first let's rearrange this. Make it like this. And then to create relationships, we need to click here, edit relationship, and then click create. Then the left one is let's start with this one, customer, and left is the customer number and no customer name, and the right is the order. So that should be linked as a customer name. We can click here. Now it's created. Then we can continue to create all these relationships. So second is the order, like the order number. Then is the item with order number. Then we can create. So this has been created as well. Let's continue with the last one. So left will be the item number. Right will be an order numbered. Great. So has been all been created. So there's one more thing I need you to remember. So we can double click this connection. You will see this window, and it's better to click this enforce referential integrity. So when you create a relationship between two tables, it's usually a good idea to click this one. So referential integrity keeps a record in the related the fields valid and correct and accurate. So this referential integrity ensures that you didn't accidentally change or delete the related data in one table, but not in another table. So which is very important. So I will click all this. So now by this means the database has been set up and all the information has been like entered, and all the relationship between different tables has been set up. And there's one more thing about the design view I will show you. So when we change back to the design view, so for the design view, you can see when you click here, the different item, you can check the properties of this each item. For example, the field size. You can define the maximum the characters in this field, and then you can have some default value. They can have any value or streams. If you didn't if we change back to the data sheet, if this is empty, then we can have some default value. Then you can also have some validating rules. For example, let's go to this one as well. So item, for example, the item, go back to design view. So the under number you can define as a between what value to what value. There is a valid item number, and also it can for the order. So no, for the ordered. So you can also specify the ordered quantity should be a positive number, not negative. So then you can define the quantity here as the validation rules, like larger than 0. So then you can define the different properties of your table. So then there's another important concept called foreign key. So foreign key is very similar to primary key. So foreign key in one table means a primary key in another table. So this concept sounds a little weird. So I will give this example to show this. So this is in this example in this table. So the primary key is actually the order number. So we set this two primary key, but in one table should be only one primary key. So the second, then the item number is the foreign key. Why? Because the item number is the primary key in this table. So in this case, we call the the item number is the foreign key. So please bear in mind. So this is a very important concept. So now let's back to the slides. So I have demonstrated how to create a blank database, how to create table, and with different design view and datasheet view, and how to set up this primary keys, and also how to create relationships between different tables, and how to enforce this referential integrity. So this part I've just mentioned, how to change or set up the properties in the field from the design view, and also how to do the validation in each field, and how to set up this relationship between tables, and what is the concept about the foreign key. And then let's move to the last part of today's lecture, is the access inquiries. So how can we process inquiries to the database? So the result of an query is on the database will be in the form of rows and columns, and the column will be the field we select, and the rows will be the records that matches the criterion we set for the query. So now we will demonstrate and how to use the Microsoft Access to do the query. So how to add a query in Access? So first you need to click the create, then you will see two ways to add the query in Access. So one is the query wizard and one is the query design. So the query wizard is I would say is a easier way. So you can add a new query by select different types, depends on your requirements. So, but in our lecture, we'll do in a more flexible but a little more complicated way by using the query design. Then you click the query design, then a table window will pop up. So then you need to add the table you want to do the query. So in this case, we'll add all the tables in this example. Now I want to query the item number required or ordered by the customer named Liam. So here I can select table customer, field customer name, and the table unlike item, and the item number. So then we'll set the criterion name, then we can run. It said okay, has already opened, then we need to close all this. Yes, close, close, close. Then we do it again. And you save the query, and then we can run it. So now you can see that all the item numbers ordered by the customer named Liam will be shown. So that's one query. Then we can go back to the design view and to have some more queries. For example, I want to query the customer field names and order other information. For example, the order, dates, the quantity as well, and item name. So now we can run. So all the information related will be shown, like customer name with the order date, with order dates and the quantity and item names. So for the query, we can also have some other criterion. For example, the date, we can specify, we only want to check the orders like between which dates. So first let's view all this information. So you can see that the order dates we have 3 different dates. So I only want to see this the date after 12th of May. So and here we can, for the order date, for the criterion, we can add this larger than the 12th of May. Then we can run again. you can see that all the order before the 13th will be hidden. So that's the criterion, and actually we can have some more criterion like the specify the quantity and the item names as well. So depends on your requirements. So another thing about query is that we can do sorting in the query. For example, we want to sort this for the delete this one. So we want to sort this quantity in for example, the descending order. Then we do the run. Now you can see that it depends on the quality, the number. We can see this order result has been reordered depending on the quantity number. So that is almost everything about the query. So we can play with it by yourself in the tutorial. And there's one more important thing about the query, or about, I would say, the database. When you click the query, you can see we have the design view, which is here. We have the datasheet view, is our results. But there's also a third view called the SQL view. So when you click here, you can see the code or the language. Because actually, even for the Microsoft Access, all the queries is executed based on this language. So this language is called the SQL language. So all the databases, not only the Access, the SQL Server, or some other called the no query or SQLite, all based on this database language. So here are some like the key keywords. For example, the select. So select will, so in this query, then go back for the select. We have select like different tables with different the field in the table. That means select. Then from, we have defined different criterion in our query. So different, then you can see from the SQL that from all the items, we haven't specify any condition. So it's actually it's all here. Then we have another condition like orders, and here's order by the item order, which is descending order. So in this way, you will show the result as a descending order. So SQL language is very important. So you can like play with it by yourself to check when you change the different setting here. For example, let's go back. Then let's put a condition like lim as well. And then let's go back to the SQL. You can see there's one more line has been added. So where the custom name equals lim, we can have more criterion like the date as well. So should be larger than this date. Let's go back to the SQL. You can see where the customer name equals Liam, and means that we have to fulfill both the condition. The order, the date should be larger than this. So this SQL language is very important if you want to learn deeper about database. So you can change with different conditions, have different selections. Then you can learn this the changes in this SQL language. So that's all of today's lecture. So if you have any questions, same as before, please let me know, send me emails, or just put your question in the forum so we can discuss. So thank you very much today.